multiply everything by the least common denominator. If you wanted to, you could try forming it. What's your least common denominator going to be? T plus 2 squared. So you just multiply this one by, you could do it this way, t plus 2 over t plus 2. So what do you end up with? 3 equals t plus 2 all over what?
T plus 2.
Correct. And then nope. No, it's not at all. So now what do? I like that. Yeah, so 3 times t plus 2 squared is equal to t plus what?
2.
Nope.
4.
Yes. So at this point, we now have a quadratic, but is it in standard form? Okay, someone besides Liv, prove to me that you're conscious and hearing what I'm saying. Is this in standard form? No, it's not. So we need to put it in standard form. So one word, what should we do? Yeah, so 3 times, what do we have? T squared plus 2t plus 2t plus 4 is equal to t plus 4. It's not in standard form yet. 3t squared plus, how many t's? We have 4 of them times 3. How many is that? 12t plus 12 equals t plus 4. This is still not in standard form. Why? Doesn't equal, and it's not all combined. Exactly, yeah. So you have 3t squared plus, what, 11t plus 8 is equal to? Is that a quadratic in standard form? Yeah, so the first hurdle is clear. We have a quadratic in standard form. At this point, what method should you try to employ, if you can? If you can, does this factor? What do you think?
Yeah.
You could try it, right? Unless it otherwise, it's going to be 3t and t, right? These two numbers have to multiply together to get what? 8, and then they need to add together to get 11 with the 3 mixed in. So you kind of have to be careful, so maybe like plus 2 and plus 4, right? But does that work? Gets you 10t. So it doesn't really work. So at this point, what should you eject and do? Quadratic formula. So a is equal to 3, b is equal to 11, c is equal to 8. What do you find first? The discriminant, b squared minus 4ac. So you have 11 squared minus 4 times 3 times 8. What's 11 times 11? Minus 12 times 8. It's going to be 24 times 4, 96. So what's that going to be? 25. Is that a nice answer? It actually is. Same with x is negative 11 plus or minus the square root of 25 all over what? 2 times? 3, exactly. So you have negative 11 plus or minus, what's the square root of 25? 5 all over 6. So how many answers do you have? So you have a negative 11 plus 5 over 6, and you have negative 11 minus 5 over 6, right? So what's that going to be? That's going to be negative what? Negative 6 over 6, which is negative 11. Not negative 11. Negative 1, right? And then what's this one? Negative 16 over 6. What's that?
8 over 3.
Negative 8 over 3. So are these nice answers? Yeah. So what does that actually mean about the original? It is, yeah, it's going to be nicely factored. That being said, this wasn't a waste. This wasn't too bad. Remember, you could sit there spinning for a long time just to find a nice factorization when you could just do this. So don't spend too long. That being said, these two numbers strongly indicate that we should be able to theoretically factor this. So
because you could do 8, you could do 3t plus 8, and
yep.
then t minus 3, I don't know.
T minus, well, t plus 1.
T plus 1.
Does that work?
Yeah.
It does work. So this was factorable. That being said, are you always going to see that? No. Just remember to spend an appropriate amount of time trying to factor it if it's something that you're allowed to do. If I said solve this by the quadratic equation, just go straight to the quadratic, right? But spend the appropriate amount of time. We did. We're like, yeah, we're not too sure. That being said, if we tried a little bit harder, might we have found it? Yeah. Yes, Liv.
If the equation is easily like
variable, p is the variable. P is the variable right here. So you're trying to find a value for b so that you get one rational solution. What part of the quadratic equation dictates the number of solutions? We only know one part of it. What's it called? The discriminant, right. The discriminant is b squared minus 4ac, right? There are 3 types of values. It's either equal to 0, greater than 0, or less than 0. If this is less than 0, what kinds of solutions do you have if it's less than 0? You have 2 what? Imaginary, because you get the square root of a negative number. What happens if it's equal to 0? If it's equal to 0, you have plus or minus 0. So how many solutions do you have? 1. And is it real or imaginary? It's real. You have 1 real. And then what happens if b squared minus 4ac is greater than 0? 2 what? 2 real solutions. These are all the number of solutions. Number of solutions right here. Number and type. So it says we want this to have, for 53 it says we want it to be 1 real solution, one rational, so 1 real solution. So what in this equation right here, what's the a value in this one? 1. What's the b value? B. And what's the c value? 25. So we want b squared minus 4ac to be, we want 1 real solution, so we want that to equal what? We want that to equal 0. Can we plug in values? Yeah, what is b? B is b, right? What's a? 1. And what's c? 25 equals 0. What's 4 times 25? So we know that b squared minus 100 has to equal 0. So b squared is equal to? No, 100. So what does b equal? Or, yes, so there are 2 answers to this. B is equal to plus or minus 10. Plus or minus 10. Either one will have 1 real solution. This right here is something you have to know. If the discriminant is less than 0, you have 2 imaginary solutions because you'll have a square root of a negative number. If it's equal to 0, when you add or subtract 0, are you doing anything to the number? No, so you're going to have 1 solution. And then if you have something greater than 0, like square root of 7, plus or minus root 7, you'll have 2 solutions. You need to remember that in green. You absolutely have to. So another one like this, let's say I gave you this one right here. Let's say I gave you this equation. At squared plus 24t plus 16 is equal to 0. Let's say I wanted this to have 1 real solution. Set up but do not solve the equation you would need to solve. Set it up but don't solve it. The thing you probably focus on as different as you see this thing, which looks a little different than what you've seen before, right? If I told you that you could absolutely solve this using methods that you've seen before with 1 slight tweak, what would you say? Any ideas? What does it kind of look like? Yeah?
Well, it has like the difference of squares. Is that what we're looking at?
That's an idea. There's 2 squares, but no, you're right. There is the difference of squares right there, but the 13 is not really nice for rooting, you know? What do you see, Nick? You could, but the problem is there's no x's in the 36. You can't really factor. That's a good idea. You want to factor it out, but the thing is, you stop having it equal to 0 if you start factoring. What does it look like? Almost.
It almost looks like that.
It almost looks like a what? It almost looks like standard form of a what? Quadratic. It almost does. In fact, it actually is something I would call like a fake quadratic. It's not really a technical term. It's a fake quadratic. What's your favorite letter, Mar? M. So let's let m equal to x squared. If I did that, you'd have minus 13m plus 36. What would the first term be? M squared. And what's this equal? Oh, wait, what's this now? What did I just make? In standard form. Oh, that's nice. Can you factor that for me? What does it factor into? Oh, come on, you can do it. It's m and m. Oh. M minus what? 9 and m minus 4. So m is equal to what or what? 9 or m is equal to 4. But what did we say m was? What was m equal to?
X squared.
So we have x squared is equal to 9 or x squared is equal to 4. So what are the answers?
3.
That's half the answers.
Positive 3, negative.
Plus or minus 3 and plus or minus 2. So how many answers are there?
4.
So this is something I would call a fake quadratic. When you see a 4th power, I have not taught you how to factor 4th degree polynomials. Can you? Oh, absolutely. You can definitely factor 4th degree polynomials. And in this case, do you know what this one factors into actually? It factors into this. X plus 3 times x minus 3 times x plus 2 times x minus 2. But is that something that's easy to do? No, not really. But is there kind of a shortcut sometimes? Absolutely. The shortcut is this something really, really, really close to something you know how to do? Yeah, I call this a fake quadratic.
Is there an actual name for that?
Not really. They just give you a method. It says solving equations that are quadratic in form is what they're calling it here. I like saying fake quadratic mainly because I think it's easier to remember and kind of more entertaining. So what we're trying to get at is we love the safety of standard form. Because once we get to standard form, what can we do from standard form? We could use what? We could factor. We could use the quadratic formula. Or we could complete the square. Right, exactly. But the thing is, are we always going to start with standard form?
No.
No. So one thing, it could be just rearranged. What I mean by that, you would need to maybe clean it up. What do I mean by clean it up? Some terms might not be grouped properly. But another thing is it might be a fake quadratic. This is what you just saw. So there's different ways. Remember how we did fractions earlier yesterday? You did fractions. There's different things. Absolutely different things. What about this one right here? Let's do a different one that looks even stranger in a way. Even stranger. So this means like new break. Let's try 4x to the 4th plus 1 is equal to 5x squared. Try that one right there by yourself for a second, and then you will share with each other. So try that first.